Oh, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under, the final session for 2018. Once again, I'm your host, Warwick Rudd, and for this month, we've got Ginger Grant talking to us about an introduction and use cases for working with Azure Databricks. Now, I will hand over to Ginger shortly. I do have a couple of slides to run you through from a housekeeping point of view, and then we'll get this month's session going. So before we start, big thank you to our sponsor, SentryOne. Without our sponsors, it makes it difficult for us to run and host these sessions for you. So if you haven't already gone across to SentryOne and had a look at their articles, videos, and various downloads, make sure you do. There is some fantastic material there to help you with your professional career. With that, stay connected with PASS, and I'll now hand over to Ginger for today's session.
Great, thank you very much, Warwick. So today I'm going to be talking to you about Azure Databricks. Azure Databricks is one of the newer Microsoft additions to Azure. Azure is a third-party application that is available not only on Azure but on AWS as well. And I'll kind of walk you through into why and when you want to use it and what it's good for. So first, a little bit about me. My name is Ginger Grant. I tweet probably too much at Desert Isle SQL. I am an author. I not only update my blog pretty regularly, but I also wrote the Microsoft Certified Trainer book for Azure Machine Learning. And I am a Microsoft MVP in Data Platform and a certified trainer as well. So now that that's out of the way, a little bit more about Azure Databricks. So what is it? It is an open source application that was created by people who designed and developed Spark. And what it really is, it's a Spark environment for developing and running applications. And one of the things that Databricks was created for originally is to develop machine learning solutions, because it is really good at processing iterative data-driven tasks very efficiently. It contains a single engine that you can use to either run a batch job, run a stream of data, and run any machine learning algorithms that you might have. It's a collaboration space also for team development. One of the things that when the people who wrote Spark looked at when they were developing the Databricks application is the improvements that they could make. And one of the big things that they saw that was lacking in the Spark environment, which is commonly lacking in a lot of machine learning environments, is the ability to work and collaborate with others in kind of a team environment. So they designed Databricks to include integration so that you can share your code within teams and also save it and integrate with GitHub. So we're going to go ahead and do that. Now, it is totally web-based. So that means that it's going to directly integrate with data that's on the web. There's no way to directly connect to data in your local data stores. And we'll go into a little bit more about how you can make that work if you want that to happen. So Databricks grew out of Apache Spark. One of the big machine learning contests that you might have heard about some years ago was a contest with Netflix where they offered $1 million to the person who could come up with a better algorithm for picking movies. The guys who developed Spark didn't win, they came in second, but they did create an application framework for iteratively processing through data. And they were primarily out of Berkeley. So 75% of the Spark code was written by a core of people who founded Databricks. And what they wanted to do is they looked at Spark and said, you know, it's kind of nice and all, but we have a whole bunch of ideas that we would like to apply to really improve the product. But they decided that instead of being part of the open source Apache collective, they wanted to make money at it. Go figure, right? So they wanted to improve upon their original product, and they wanted to create this in-memory processing framework that Spark uses. And they also wanted to harness the cloud because they wanted the ability to infinitely scale. The first place they released their application was in the AWS cloud. And the second place that they added it was to Azure, and they added that in March. One of the cool things about having it in the cloud and using cloud resources is one of the problems that they felt they really wanted to solve is the ability to scale infinitely, well, nearly infinitely, depending upon the tasks that you need. So that's one of the cool things about Databricks is when it realizes that you need more resources, as long as you've, of course, allocated them, you can scale up your environment so that you can run very large jobs very efficiently. So it runs based on Spark. So what is Spark? Well, Spark is part of the Hadoop collective. What that means is that Spark was designed to run on HDFS file clusters. And it's a way of breaking the data up that's stored in those file clusters to simultaneously read the data. So what it does is it takes data in that file structure and breaks them up into parallel processes. Reads that data and caches it into memory, and then runs the same processes on every little group of data that it has, and it does that extremely quickly. Now, in order for Spark to work, and again, Databricks to work, since it's fundamentally the same technology, this was designed for an HDFS cluster. So Spark and Databricks need to have their data in that environment prior to doing any of their analysis on it. Well, what does that mean? That means you are always going to be copying data to an HDFS cluster. Within Databricks, it's the file structure within Databricks. This is why you're not ever going to be able to directly connect it to any database, because it has to be in that file structure to take advantage of the underlying technology. It's pretty seamless, but it's never going to be a direct connection into your data source. And it also handles streaming as part of this processes, and also it has a data frame API as well. So it was uniquely designed to do a lot with machine learning. One of the cooler applications of machine learning that I've seen recently that involves using Databricks was one that you could find, I'm sure, on YouTube, where Microsoft is doing some analysis of video of snow leopards in various places in the wild, and using machine learning algorithms to determine if that blob is the landscape or actually a snow leopard. And one of the ways that they were able to do this is by using Databricks, because they need to look at large amounts of data. In this case, the data is video, but it could be anything, and processing algorithms against all that data at the same time. And that's what Databricks does. That makes it really ideal for machine learning. Because they designed it with this in mind, they natively support R, Python, and of course Scala as well. I didn't list it because I don't use it as much. And you can run your processes as batch or streaming. But they did also wanted you to use standard analytic solutions that you're probably familiar with. So you can use SQL to query the data that you've got stored in HDFS. It provides the ability to visually review the data that is there, handles multiple languages, and handles libraries. If you use R, Python, or Scala, you know that you want to use a number of different libraries with it. So you can load the libraries up within Databricks as well. So if you want to use NumPy or MyPy, or if you're using R, if you want to use a tidyverse, all those, you can load any and all libraries that you want to. So you kind of own your space. And you have the ability to store quite a bit of data with it. The reason that they've added these tools is they want to make it an environment in which you can, do some and analyze the data very quickly, do some visualization, collaborate with groups of users by being able to share your code, check your code in and out of GitHub, and then look at providing insight to the whole team. So it is actually a managed service offering. So it's integrated with Azure AD Security, but when I show you it in a little bit, you'll see that you pop out of Azure to go into Databricks. The reason it has such a unique environment is, again, it's a tool that Microsoft is licensing for Azure. So, and they are also, Amazon is licensing Databricks for AWS Cloud too. So it's really a separate application designed for cloud usage. So it works with Microsoft tools, but it is not a Microsoft tool. But Microsoft wanted to make sure that they supported it in their environment because there's such a big demand for it, because people really like the way it works. Especially the group development environment. This is a common theme when you're talking about a lot of different data science projects, is how to productionalize it, how to share it, how to make this more than like a one-man show. And that kind of environment was thought about and included within the environment. So the runtime is serverless. It uses Apache Spark and Spark's ML, but it uses the Databricks interface. It also has the ability to run jobs, so that you can schedule within it as well. And it can be its own kind of standalone environment. And of course, you can include anything you want to within there. So how do you access data for Databricks? Well, there's a couple of different ways that you can do that. You can, of course, integrate this with Azure Data Factory and call your Databricks jobs from there. If you have data that you've got, say, on-prem, and you want to load it up to be able to do Databricks analysis with it, you're going to need to bring it to the cloud. And you're going to need to do that prior to entering the Databricks environment. And that may be one reason you want to integrate it with ADF. So you're going to need to take the data and put it into Azure, and then from there it needs to be copied into the Databricks environment so that it has it in the HDFS cluster that it processes against. So you can't access any other data in the Azure cloud. I was talking to somebody recently and they're like, well, it's Python, so I could do some like Python, JDBC thing to get at my data. No, you can't. That will not work. You need to have all of your data in the cloud prior to it being able to be accessed into Databricks. So if your data is not there, create some process initially to put your data into the cloud. Yeah, you could definitely do that with an on-premise server using a data gateway, put that into a blob, and then use the blob from there. So it is. And the reason it is like this is it is a very secure environment. There are no tunnels that are allowed to anything on-prem. That's not how it operates. It's just totally cloud-based. It uses Azure AD to be able to access it, and you are be able to grant rights to people based on that security. So it is a completely integrated environment, and you can write code within it. And you write code within it using Jupyter Notebooks. Jupyter Notebooks started out as IPython notebooks. If you're really interested in a lot about Jupyter Notebooks, I did a webinar for another past virtual chapter earlier in the year that I know you can find on YouTube if you go look at it. But what you can do with Jupyter Notebooks is it allows you the ability to store both your code and your data. And you can take those files and integrate, use them locally or pass them around or include them within a notebook. So it's an environment that it's gotten really common for writing code. As a matter of fact, there are over 30 languages that are now supported within Jupyter Notebooks. For formatting, which of course you can do with the code, you can use Markdown. So you can integrate, make your analysis look very pretty in addition to having all of your code there. Now, you may not wish to write everything within Jupyter Notebooks. It does not have some of the features that you may be relying on in a standard development UI, such as no IntelliSense, but it's definitely getting to be a more common way that code is being written for a lot of the more modern languages. So this collaborative environment that's included, the reason that they did it this way is they realize that generally speaking, a lot of the applications are being written in teams with people. So multiple people need to access the same files. Since this is designed to be production ready code, you need to be able to version it and to put it in GitHub. So the environment comes along with it. It's nothing additional. It's considered part of the Databricks application. So it's an interactive team environment. You can, of course, add people to the team, and they will have the ability to access and use information that's being presented. One really cool thing about how the whole integrated environment works is it's been set up so that it won't kill you in Azure dollars. by default, it will turn itself off in 2 hours. Of course, you can turn that off, but it's really kind of a nice safety feature because, like me, if you've ever like accidentally left something on overnight and you're like, oh crap, there goes all my Azure money, you won't do that with Databricks because it will shut itself off, and is also designed to auto scale based on the load. And there's 2 different flavors of it, which we will go into when it comes to pricing. So there's 2 major tiers, and the 2 major tiers are standard and premium. So with the standard environment, you do not get the full integration with the teams. There are some options that aren't available to you, and we'll go ahead and take a look at those. So, but if you want the full working with teams environment, then that's when you're going to need to use the premium tier. And there's 2 different workloads, data engineering and data analytics. Data engineering doesn't include interactive clusters in the standard tier. So if you're looking for interactive clusters, then you're probably going to want to move towards data analytics. One thing that is nice, if you would really like to try this out and you don't want to, you don't want to spend a whole lot of money doing that, there is, of course, a free trial, and it's for a premium for 14 days. So you can go ahead and take advantage of that, play around with it, see how it works, and then decide what you want to do with it. If you want to make that premium tier live, of course, they allow you the ability to do that. So how do you get started with Databricks? What do you do with it? Well, the first thing that you do is you create a cluster. A cluster in Databricks is a resource, and you create this resource to contain so that is where your code is going to be run. And then you will load your data, some kind of a reference data source. Then you're going to go ahead and take a notebook and write your code for it. Take a look at some dashboards, create a data set, and then perhaps implement a runtime solution and schedule an ongoing running of your job. If you're doing Databricks to do ML, the steps that you're going to basically doing right now, if it's a standard thing, is write some R Python code, maybe rewrite the code in Java, or write a web service or API to implement, and migrate the code to SQL Server or to a web server. All these steps are being replaced by just using Databricks to write and run all of your code. So I'm going to go ahead and enough talk and show you how Databricks works. But first, are there any questions that have come up that now would be a good time to answer, Warwick?
Not at this stage, Ginger.
Okay, great. So creating to create a Databrick environment, what you're going to want to do is going to go ahead and say create a resource here within Azure. And it is under Analytics. And then you can go ahead and create a Databrick. I'm going to show you how to do this, but I'm going to use an environment that I've already created because this does take about 20 minutes to load, and I don't want to bore you with waiting for a Databricks environment to be created. So you can just enter a workspace name. I'm just going to call this and this is my subscription. I'm going to go ahead and create a new resource group and location. And I know that this is important for a lot of people on this call. It is available in Australia and for different data centers. So you can put it there. And then the pricing tier. So the standard version, again, this does not allow you all of the workspace controls that you get with premium. And if you want to do it for free for 14 days, that's what you selected here. So if I did this and went ahead and hit create, and 20 minutes later, I would have an Azure Databrick service. Like I said, I'm too impatient for that. So I'm just going to show you what it looks like when I actually have one created. So within Azure, I have a bit of information available to me. my activity log that I can take a look at here. Not a whole lot. Shows me some things that are going on, because really everything that you want to do within Databricks is within its environment. So if I go ahead and say launch, it's putting me into a different environment. And notice I had that brief message saying that it's signing me in. So it is signing me in using my Azure AD security. So this is what it looks like. I notice I'm in a completely different environment than what I was in before. And I have some different different options available to me. So this is the page that we're on right now. The home page shows the various notebooks that I have available. In my different workspaces, I have just the one right now. It shows me a list of my recent Jupyter notebooks that I've created, and also my data. And these are the data sources that I have here. I can add data from a number of different locations, but the first thing that I would do if I was coming into create a new Databricks environment, the first thing I would want to do is I would want to create a cluster, because a cluster is where all of my work needs to be done. So step one, when you are doing anything with Azure Databricks, is to create a cluster. So I'm going to go ahead and create a cluster name. And if it's high concurrency, this will not support Scala, and it's optimized to run for concurrent SQL and multiple workloads. So this will handle better for streaming, and a lot more clusters if you are going to use those. Or I have standard. It have my options of what I can select in terms of languages. So you can do the latest Apache Spark, latest Scala. Now for Python version, for those of you who aren't that familiar with Python, one of the things that Python created a new version called Python 3 10 years ago in 2008. And if you haven't written any Python code, don't waste your time writing any Python code in version 2, because it is not supported as of end of this year, and it is going to be falling off any kind of support model. So I'm really upset actually that I have to bother to pick 3 every single time. Now with this cluster is going to be an HDFS cluster, so I have to determine how many cores and drivers that I have. So it lists the different options that are available. There are some different charges for these. So if I pick the standard with the 256 memory and 64 cores and 12 GPUs, this is going to cost me more than say something that is more light in terms of the number of cores. So I could, if I want to just do something lighter, then I could go with say standard F4, which will decrease the amount of Azure dollars that I'm spending on doing this. Notice the GPU accelerated is not available. You're going to want to, when you are creating your Databricks, is look at what location you're doing it, because GPU accelerated is not available in every single data set, and I picked West US2, and that is not an option here. So what the other thing that I can do, of course, is I can set my environment for the driver type and for the worker type, and this shows me the minimum number of workers and the maximum number of workers. And this will allow me to enable auto scaling. So if I want the ability to use as many workers as possible, so scale up when I need it, if this is checked, which it is by default, then it will go ahead and auto scale for me. And this warning basically is telling me about my account, because I've got a number of different clusters already defined. It's telling me, you're going to kind of hit your maximum on this, so that I need to probably modify some things in my environment to be able to use as many cores as I want to. For auto termination, Generally speaking, this is by default. When you check this, you get it. It will terminate after 20 minutes of inactivity. This means that after 120 minutes, nothing is running, and no charges will be incurred. So it'll just sit there quietly, and nothing will happen to it. Now this takes about 15 minutes. So in the interest of not wasting your precious time watching things spinning, I'm going to go ahead and show you what it looks like when I've got a cluster created. So I've got a cluster here that is running. This is a standard VS V2 cluster, and it is running Apache V2 and Scala 2.1, and it is currently all the things that are running at it. So once I've got my cluster created, then I can go ahead and load up some data. So what I'm going to do is I'm going to take a look at what I would do to actually load some data to my environment. Now I've got a number of different ways that I can bring data in to my HDFS cluster so that I can run Databricks after it. Go ahead and click on Add Data. Now I can add data from various places, including from a file store or other data sources. So if I've got data in Azure Blob Storage or in Azure Data Lake store, I can reference it here. So I don't necessarily have to put data into this environment. I can reference existing Azure Blob Storage or Data Lake stores for my data and reference them within this environment. Now I will copy them over because that's how it processes these things, but these are the options that you have. So, and JDBC, this would have to be from another Azure storage location. But what I'm going to do in this particular time is I'm going to look at uploading a file. So I can do that by browsing to a file. And I could go ahead and browse to some airplane crashes. I was doing some analysis on, what airplane crash data look like. So I want to make sure I don't have this one up here. So I'm just going to put a 2 after it. And I'm going to go ahead, oops, file not found, idiot. I'm going to go ahead and open this one. And it'll go ahead and upload my file to airplane crashed CSV. So then I can go ahead and create a table. So if I create a table, it's going to ask me what cluster I'm going to read and preview the data. This is why I needed to add a cluster before I went and added my data. So I'm going to go ahead and select my cluster, and then I'm going to go ahead and preview the data that I have here. So it's telling me it already exists. So I'm going to have to look at, let me do this again and put the right name on it first so I can show you how I did that. Oh, here we go. I did it anyway, pulled it up anyway. So you can see what it's doing. It's telling me that what I have here is structured data. Let me go ahead and take a look at this data. I'm pulling that up here. And you can see this is a simple CSV file that is showing you the location, the plane type, and this is for crashes. So it's going to say, dead, aboard, and ground. Let me do something here real quick to my data because I wanted to show you exactly why I might be able to not do certain things here. So I'm going to go ahead and filter it. And you'll notice that it's mostly dates in here, but I think I've got some blanks that's going to go ahead and load. So it's loading these up as dates. It recognizes these. For this, I don't have any blanks. For aboard, it tells me how many people were aboard. It's all numbers. And for ground, I've got something called, I've got NA in here. So since I have something that is included in my data set that is not a number, I won't be able to call this a number because it's got some text in it. So some things to know when you're looking at your data, because if you try to change your data type to something you can't do, you'll get an error. So what I can go ahead and do is, change my data type. So this is designed to be text, I can make this integer. And I'm going to have to leave this as string. The other thing that I can do here is I can select the first row as headers. So it'll go ahead and put my table names up here instead of just calling them C1. So I've got my names up here. And then I can go ahead and create this table into a notebook. So I've got my data loaded, and it is structured data so they can take a look at it. So I'm going to go ahead and create my table in Notebook. So what this will then do is creating a data frame for me, and it gives you a little bit of a description as to what that would take. So it's going to create a file store within Databricks, again using the HDFS structure. Then it'll go ahead and load that. So then I'm going to go ahead and run these, and with this is a Jupyter Notebook. So with Jupyter Notebooks, I can go ahead and run the individual cells by clicking on Run Cell in the right-hand corner here. So I can just say Run Cell, and it's telling me that it wants to attach to my cluster to be able to run, because again, I need to have a cluster to run anything. So I'm going to go ahead and tell it to automatically do that. So attach and run using my cluster. So what it's going to do is it's going to go ahead and, oh, it gave me a file scheme error. That's weird. I don't know what that's about. Let me open up another one where I have done this, and so that I know works fine. For some reason, I'm getting a silly error. So I'm going to go ahead and look at my crash here. And this is showing the fact that I have my information crash. So let's go ahead and clear this, and so I can confirm. So I'm going to go ahead and take the table that I created called Airplane Crash and show you the data that's contained within it. So I'm going to go ahead and run this. And when I do, this is very similar to the information that we looked at earlier in Excel. I'm taking a look at the data, and it's telling me the date location operator and the who is dead, how many people were aboard, and if it was hit by the ground. And this is only going to be showing us 20 rows. And then again, I'm using Python, and you can see that because that is specified here. So I can go ahead and take a look at the schema. And if I do that, I can see that this is specified as string, location is specified as string, operator is string, plane type is string, and then dead and aboard are both integers, and ground is string. I made that string because, remember, it had some NAs in it. So one of the things that is really cool about Jupyter Notebooks is I can go back and forth from various languages. So this is obviously is Python, but I have also the ability to change using this magic command with a percent sign in front of it, so that I can actually query my data as if it was SQL. So I can say, okay, this is my table, it's called Airplane Crash CSV. Can you just show me all of the records where dead is greater than 50? And if I run this, this will just show that set of data. I still, of course, have all of the data within the data set. I'm just visually looking at less data than was in the data set. So then I can bounce back to running some Python and just select the rows where the column where it's just where the people are dead. And it's just going to show me that particular column. So one of the things that you'll notice when I ran this particular job and when I ran this SQL job is I've got these little different icons at the bottom. Let me take a look at them here. What this is going to allow us to do is it allows you to see some different visualization options. So I can just view this instead. All I need to do is 2 for scatterplot. So I can do a bar chart, and this is just showing the different numbers of dead. I have the ability to do different visualizations, or I can go back to looking at a grid. I also have the ability to download the preview or the full results to my out of the cloud should I wish to do that. The other thing that I have the ability to do, very commonly used in Python, is to look at some pandas data frames. So I'm going to take my data set, which I have here in DF, and I'm going to create a pandas data frame and then use a pandas head command on that data frame. So I'm going to go ahead and run this. And so this is just showing me that I've got my head, which is going to show me for just the first 5 rows of the column, and it wrapped it around, which is why you're seeing them like this. So you also have the ability to do lots of different visualizations that you can do in Python. So here I'm actually importing a new library. I'm going to be here. I'm importing the Seaborn library, which allows me to do some prettier visualizations. And I'm going to go ahead and plot that as a histogram. So I'm going to go ahead and run this. And when I do, I have a little prettier graph that shows me dead versus the number of the board using the standard Seaborn library. And I also am going to go ahead and do a count here. And it's just showing me how many NAs I have because I'm curious to find that out. And it says I've got 26. So if I look to do just a group by counting the number of dead and displaying that, I can see how many grouping by dead and count. And there's 100 where there are 148 people dead, there's 2. So you get a different idea of some of the analysis that I can go ahead and do when I'm walking through, when I'm walking through Python code. So it allows me to do some analysis, and I also have the ability to do some more advanced stuff. The other thing that I kind of wanted to show you is within my various jobs that I can do something a little bit more interesting than perhaps just doing some simple analysis of my file. I can actually look at doing some linear regression, taking a look at, doing some more complicated code, looking at analyzing that and displaying the figures here. So something a little bit more complicated. So I'm going to go ahead and run these and looking at doing some map, importing some matplotlib, and then doing, I thought I said run them all. And now displaying a figure. So I'm taking a look at doing some linear regression and doing a little bit more advanced kind of Python that I might be doing for some more in-depth data analysis. So we kind of took a look at some of the code that I could run in Databricks. But you may be thinking to yourself, all right, that's cool, but I could do all that on my machine. Why would I necessarily want to do it in Databricks? Well, a couple of reasons. For one, like I said earlier, you do have the scalability so that you have the ability to use a number of resources in your job. You can scale it. So how many clusters do you want to use? How long do you want it to take? You have that capability to expand that. You can, of course, work with Azure Data Factory to store your results too in Azure databases. Again, my output is going to go back to the same place that I could put my input. So I can put it to a Data Lake or Blob Storage natively. If I wanted to go to another output, then I would need to perhaps do something with Data Factory to do that. And I can look at automating the process with Databricks jobs. So while I can use Data Factory for scheduling, I don't have to. I can do all of my scheduling within Databricks using jobs. So what are jobs within Databricks? Well, they're really similar to SQL jobs. You can run code inside your notebook on a schedule, and you can use an existing cluster, or you can create new clusters. So generally speaking, when you want to do this, a Databricks jobs, you can have multiple owners. And when you have multiple owners, you can send notification emails based on the status, is it running? How long did it take to run? Did it fail? Did it run greater than X number of time? You can set alerts for failures, and you can have reconfigurable retries. Perhaps you're waiting for data to show up in your blob store prior to going ahead and running your data job. So you can say, retry this 3 times. You can tell it how much you want to scale. Do you want to infinitely scale? Do you want to just scale to multiple CPUs? How do you want to do it? The job can specify that. The other thing that you can do with Databricks that makes it a really cool application that you may find more things to use with it is it allows you can do structured streaming. So if you have data that is coming in at a pretty rapid pace, it's coming in all the time, you can continually run your Databricks jobs. So it integrates with Kafka to process the data, and you can get interactive status metrics so that you can take a look at how it's running all the time. So you have, in essence, what's considered kind of an unbounded table where you're running your data and then processing it as it's coming in. The other thing that you can do with Databricks is you can do a lot of interesting stuff with deep learning. Deep learning tends to take a long time because it takes a lot of data to train the model, and the algorithms used to process it are pretty intense. It natively supports TensorFlow, Keras, and CNTK, some of the more common algorithms, and you can use those to create neural network ML processes. So let me take some time now and show you some of the cool, more production features of Databricks so you can see those as well. So going back to Databricks, let me go ahead and show you some of how the jobs work. Now, what I created is I've created here an existing job where I'm running a notebook, and I've run it every day at 4:20. And what this notebook running is doing is it's allowing me to run it or run it with different parameters. So I can tell it that I have dependent libraries or not, and I can look at the schedule. The other thing that's kind of cool here is that you can see that how long it takes to run. Now, when you are creating a job, one of the things that you can do is you can use an existing cluster, or you can create a new cluster. You'll notice that all of these have different numbers on them. These are the names of all of the clusters that are being automatically created. And the reason that I'm having it do that and having it run on new clusters every single time is because when I do that, I don't have to have a cluster running. It creates one, moves my data to it, and runs it. And this allows it to use the resources much more efficiently. So that's why I'm that's what these particular numbers mean. So that's why you, generally speaking, always want to create a cluster when you are using and when you're running a job, and it gives me the status of the job. So let's see how I could go ahead and create a job. So I'm going to go ahead and go into jobs here, and I'm going to go ahead and say that I want to create a job. And I'm going to call this, and it's going to ask me to select notebook, select a jar, or configure Spark Submit. So what I can do is I can take one of the notebooks that I already have and go ahead and run those. I can also create folders of notebooks too. So this is my data though. So I want to, oh, come on, look at, looking for a particular one. And these are the ones that are particularly assigned to me. Notice that this is a environment. So if there are multiple users on here, I could select one from a number of different users. So which one did I want to go ahead and do? Let's see. I'm going to go ahead and pick test. So what this is going to do is it's going to ask me if I wanted to have any parameters that allow me to create a schedule. I can run it every hour, or I can run it every day, and I can run it, say, I'm at Pacific time. I could run it for 8:20 Pacific and say confirm. I can also go into advanced, and I can have a number of different alerts that I can create. So I can enter a list of addresses to send an email when something starts, on success, on failure. If I skip it, I don't have to send anything. So I've got these options out of the box. The other thing that I can tell it is how many concurrent runs do I want? Do I want to run this multiple times at once or not? Timeout. How many times do I want to, how much do I want to, if it times out because it takes a long time to load the data, what do I want to set it out? Do I want it to, run for a long period of time? And the other option I have here is retries. So I can tell it to say, hey, do this 10 times and wait 3 hours between. Or I could tell it that I wanted to retry on timeout. So I've got a number of different options available to me here. I'm going to go ahead and say cancel now. So what I can go ahead and tell it that I want it to run now and go ahead and run it. And it's telling me that it's going ahead and doing a manual run. Some of the other functionality that you also have available to you that I talked about was looking at my various settings that I have. So I can look at my user settings here. And I've got Git integration. So here is where I would integrate this to GitHub so that I could have all of my data that is stored off into GitHub and save it off there as well. So it's not just stuck in here. I can also set some specific commands in my notebook to turn things on and off, turn on Advisor. I also have the admin console. And when I have the admin console, this is where I can add a number of different users. Notice that it's telling me that it has to belong to the Azure Active Directory tenant of your Databricks workspace. So you need to manage this within Azure, but I can go ahead and add a number of different people. I can go ahead and give them cluster creation or not. I can create different workspace storage, permanently get rid of all revision history, or cluster logs. And for access control, I can enable it, and this is telling me that this is only available in the premium SKU. Now I do have this is a standard SKU, so this functionality is not not something that I have the ability to take a look at. But if I go to this cluster, this is a premium SKU. So if I go to admin console here and look at access control, it tells me that I can enable this. So what this means is this is allowing me to put more controls onto who can edit, view, and run workbooks in their workspace. So this is a kind of more interactive environment, and this is what you get with premium that's obviously not available in standard because we just saw that wasn't available. So again, what this can tell me what users can do with clusters, whether or not you can enable access control. So you can enable the effective if the cluster access control is turned on, so that way these things can coordinate, and personal access tokens. So what this means is that you can create personal and as well as stuff that can be shared within your Databricks console. So you've got a bunch of different options within here that allow you to work with other people, save your stuff off, run jobs, prompt your jobs, and kind of take a look at that kind of information. Kind of a neat environment, because you're not just getting a place where you can just run stuff, but where you can work with other people as well. So I'll go back to jobs here, and you can see that I've got it that this is still running. But you can see, like this is, what a standard run will do, and take a look at the number of different runs that are available, and you can increase this past 60 days, but if I go ahead and look at here, it'll give me what the output was. So again, this is the job that we looked at earlier, where I'm looking at doing some linear regression. Again, I can code this so that my output goes to a blob store, so that I could analyze it outside of Databricks should I want to do that as well. But I can't directly integrate this with SQL Server. Just kind of remember that when you're doing it. So we went through and took a look at Databricks jobs and kind of, looked at why you would want to use Databricks. It's pretty flexible. You can write code with it. You can share with it. It will scale. It's really very good for writing machine learning. It runs R, it runs Python, it runs Scala. You can add libraries should you need them. You can add visualizations. It uses Jupyter notebooks. You can, have it run a number of different clusters. You can scale it and you can schedule it, and it will send you emails. It will do retries, a lot of things that you would kind of expect for a standard kind of production ready application to do. With that, what I wanted to do is let some time if anybody has any questions about Databricks.
Okay, so we haven't got any come through so far, but as Ginger has said, if you've got any questions, type them away in the questions section. We're able to then answer those. While we do give a couple of minutes, if there are anybody who does have any questions, just to let you all know, this session has been recorded and will be available on the DBA Fundamentals website in the archive section, where you can come back and watch not just this session, but all of the sessions that we have run for this year, as well in this time zone, as well as in the North American time zones. So if we don't have any questions, I'd like to say a big thank you to Ginger for coming along and presenting to us this month. I'd like to big thank you to all of you who are part of this session, and I look forward to seeing you all in the new year for a brand new 12 months worth of learning sessions.
One thing that I did want to bring up, because I get asked this question a lot with Databricks, is what the difference is with some of the stuff that you can do with this versus what you can do with Data Lake and SQL. Again, Microsoft didn't write this application, they're licensing it. And I have heard that given the wide adoption of Databricks and this is again rumor, this is impacting what their decision is on data lakes. I don't know that they have necessarily made some, but I would look in the future to see the impact that Databricks has on data lakes, because I imagine that it will be significant, and Microsoft may change what they wish to do in the future based on the very big success that they've had with this product.
Okay, so Ginger, I have an existing Azure Databrick which data scientists are using to run their jobs. From time to time, people feed back to me saying the jobs seem to hang. Even though I've increased the amount of memory and number of cores, how do I determine the issue?
If the job seems to hang, does it mean that it just doesn't seem to run, or it's taking twice as long?
We'll give...
Yeah, give the person a think, because depending on what your answer is. Now, I will say that there can be quite a bit of differences in running based on just how Azure works. I've seen the time vary about double. It does complete, but sometimes it just seems to take twice as long, and I do not know why specifically that it does that, but I can just tell you I've seen that happen.
Okay, so we got a response back saying that it doesn't complete.
Doesn't complete at all? I would do two things. For one, I would look to see if it is, look at the log to see if the logs that exist on the job to see if you can see that it's hanging specifically, or if it's continually not completing, that might be something that you might want to address with Microsoft, because there may be some contention on the specific server that you happen to be on. Generally speaking, though, if you have a job that runs all the time, then sometime it doesn't. Generally speaking, it's probably an unhandled data error, but I'd kind of have to delve into it to be able to the logs to be able to determine that.
Thank you. Do we have any other questions before we sign off for this month? Okay. So okay. Are there plans for additional languages to be added?
Actually, from what I have heard, no. Because the data, again, this is not a Microsoft question, this is a Databricks question, and they are more interested in making it go faster with the languages that they have, rather than adding anything to it. They don't seem to be interested in adding languages to it, and I'm not really sure why, but this has come up.
Thank you. So no questions, but some feedback. Great job, Ginger.
Thank you.
And happy holidays to all. With that, we'll round out this month's session, and I look forward to seeing you all again next year. Thank you.
Thank you.